So here, let's think about some implicit differentiation. So let's suppose we have y times cosine of x equals 5x squared plus 4y squared, and we want to find dy dx. So what we do is we take the derivative with respect to x of both sides of the equation. Now, when we're going to be taking the derivative with respect to x, what we have to remember is that every time we encounter a y in the equations, this y is actually a function of x. So even though we just wrote y, we really mean y of x. So every time we see a y, we think y is a function of x. And that means that we might need the chain rule sometimes, and we need to treat y as a function and not just as a variable like x. So let's see, here we have a product. We have y, which is a function of x, times cosine of x. So we need the product rule. So we want f prime g plus g prime f. Now in this case, f prime, since f is y, is just dy dx, and g was cosine of x. Now the derivative of g, the derivative of cosine of x, is minus sine of x times f, which in this case was just y. Now to take the derivative on this side of the equation, well, since x is just a variable, the derivative of 5x squared with respect to x is just 10x using the power rule. And now what about this? Well, we have y is a function of x, so we're going to have the power rule in play, so we're going to have 8 times y times, because of the chain rule, dy dx. Okay? And now you could go through and solve this for dy dx if you wanted to by collecting all of the terms that contain dy dx on one side of the equation and moving everything else to the other side. Now, what about this other problem where we have something like 2x cubed plus x squared y minus xy cubed equals 2. Let's suppose we want to find dy dx here. Okay, so again, we take the derivative with respect to x of both sides of the equation. And this is really important right here, to not forget that when you take the derivative with respect to x of a constant, you always get 0. This right here is probably one of the most common mistakes that students make, and they just leave this as a 2 instead of taking the derivative of 2, which is 0. Now on this side, remember we have to, everywhere we see a y, we think y is a function of x. So every time we see a y, we really think y of x. So let's see. So the derivative of the first term is just going to be, it just contains a variable. So in this case, we're just going to have 6x squared. Now here, though, we have a product because x squared is a function and y is a function. So we'll let f be x squared and we'll let g be y. So we want f prime g plus g prime f. So here I'm just going to move the 6x squared down and leave myself some space. Okay, so now in this case, f is x squared, so f prime is 2x, and g is just y. Now g prime, well if g is y, g prime is just dy dx times f, which in this case is x squared, minus, now in this case again, we're going to need the product rule because we have the function x and the function y cubed. So we're going to use the product rule, and we're going to just put this minus sign here out front. Now we want f prime g plus g prime f. In this case, f is just x, so f prime is just 1, and g is y cubed. Now what is g prime? Well, we have a function of x cubed, so that would be 3y squared times, because of the chain rule, dy dx. And that's because y is a function of x. So if, for example, I had something like sine of x cubed, how would you take the derivative of that? Well, it would be 3 times sine of x squared times the derivative of sine of x, which is cosine of x. So in our case, this is just y, and that's where the y prime comes in, and this is where the y comes in. Okay, so now in this case we have 3y squared dy dx for g prime times f, which in this case was just x. And now we can go through, and all of this equals 0. So now we can collect all the terms that contain a dy dx on this side of the equation, everything else on the other side, and then solve for dy dx.